Today's problem is possible words from phone digits, difficulty medium. You are given a keypad as shown in the diagram and an array containing digits. Your task is to list all possible words. I mean, by words, it doesn't really mean actual words, but list all possible combinations of letters in any order which can be generated by pressing numbers in the array sequentially. Numbers 0 and 1 do not map to any letters. You can return the words in any order. The driver code will print them in sorted order. Example 2 and 3 is the input. Now 2 will map to the letters A, B, and C. 3 will map to the letters D, E, and F. So all the possible combinations would be these right here. You know, we can start with an A and map the D, E, and F. Then we can go to B and map the D, E, and F. Then we can go to C and map the D, E, and F. This one's a little bit simpler. All right, array size will be somewhere between 1 and 9, and the elements in the array will be between 0 and 9. Expected complexities 4 to the n. All right, that's an exponential runtime, and it's not good at all, but the numbers that we're dealing with are pretty small, so it's manageable. It's not an efficient algorithm. It's not something that's going to work with a large amount of data. Topic tags, array strings, method, recursion and backtracking. That's the main thing. 4 to the n, where n is the array size. Well, we get the 4 because a couple of these letters do have 4 possibilities. And we're going to get somewhere between 1 and 9 numerals to work with. So what is 4 to the 9th? 4 to the 9th would be like 2 to the 18th. 2 to the 20th is around 1 million. So that's a manageable number of operations. All right. There's a similar problem to this on LeetCode. It's a little bit different in that the LeetCode version will not give you zeros and ones as part of the input. This one, it actually will give you zeros and ones as part of the input. And so you have to handle those accordingly. How are we modifying the solution to handle the fact that we may get zeros and ones? All right, well, so here's one thing is we're adding a couple of empty strings here at indexes 0 and 1. Now, the LeetCode version, you don't have to do that because you're not going to get you're not going to get zeros and ones. The other thing is that, well, let's look at what we're doing here. Result equals array list. It's an array list of strings. That's our result. That's what we're going to return. It's a class variable up here, so we don't need to pass it to the backtrack method. Digits. Well, again, digit, that's a class variable. So we don't have to pass it to the backtrack method. And then we call the backtrack method. Now, we start out calling backtrack with an empty string and a length of 0. we have to keep track of length separately. You see, if we're not going to get zeros and ones, then we can use the length of the string as an index into the digits array. But if we have zeros and ones, those are not going to give us any letters. So potentially we process more digits than we have letters. So we can't use the length of the string. We have to keep track of it ourselves. And you can see we're passing it in here. All right. Here's our base case. If the digits length, that's the length of the array, equals length, that is, it equals the number of digits in the input array equals the number of digits that we processed, then we have a result, and we'll take that result and add it to the list of lists. All right, digit. So that's how we get the digit that we're currently processing. We take length as an index into the digits array, and we get a digit. If the digit is less than 2, we're not going to get any letters out of that. But it is important that we increment length because we want to get the next digit out of the digits array. So if we encounter a 0 or 1, we're not really going to do anything with it other than to make a recursive call, but we have to increment the length. All right, let's kind of see how this might work with this example. Actually, I didn't really show this whole array here, but this array is this will index a digit to the letters represented by that digit on the phone. What do they call it? Phone digits. Okay, we'll map digits, phone digits to letters. All right, let me scoot this back a little bit. Well, look at this. Where the input array is 2 and 3, all right? So, first thing that happens is we call backtrack. The string is empty. Length is 0. This is checking whether we have a complete, whether we have a complete word, and we don't. So we'll get digit. Length is 0. Digits at 0 is 2. So the digit is 2. Is the digit less than 2? No. So for every character, we're looking at the map here. Here's the map. The map for 2 is right here. So for every one of those letters, we're going to add it to the string. So let's add an A. And then we'll call backtrack with A and 1. We come in here with A and 1. We don't have a solution. The digit's length is 3. It's not less than 2. So now we go up here to map digit, which is D, E, F. And for each of those characters, we're going to add it to the string. So first thing we get is AD. Increment the length. Come up here, and AD has the length of 2, which is the length that we're looking for. So we'll add that to the result. Here it is, right here, AD, and then return. All right, once we return from that, we can move to the next digit, which is an E. Put that on, and we'll come back up here, find out that's successful. We get AE. The same thing will happen with AF, and then we are done with that. Once we return from that, we are at the point where we have exhausted the possibilities of the letter A. So we move to the next letter in this. We're back on digit 2. Okay, so we'll move to B. And we'll go through the same process again, where we will append a D, E, and F. Then we will move to letter C. We will append a D, E, and F. My concern about this is whether or not we're processing the zeros and ones correctly. I did run one test on it, and it seemed to be okay. But anyway, let's submit and see what happens. All right, very good. So actually we've had like two or three of these in a row where we were asked to do recursion and backtracking. So similar pattern. Go ahead and like the video. You know, you should feel comfortable with the pattern, with a backtracking pattern. It's a common problem-solving pattern. And you can subscribe free of charge to the channel, and we will see you next time.